on to the next part of this question. So here we have a transformation problem, all right? So the diagram below shows the quadrilateral P and Q. All right, so we have two quadrilaterals, P and Q, and they want us to state the transformation that the image of Q undergoes from P. All right, so what do we have here? Let's just take a close look at our shapes. So we have quadrilateral P, which is a trapezium, and when we look at the quadrilateral Q, it's still a trapezium. So we see that nothing has really changed in terms of the shape or its size. So that already rules out dilations and enlargements. But we do see that the shape has moved. All right, it has moved from its original location where P is and moved down to where Q is. Now, it's not a reflection because it's not the same distance away from any sort of mirror line, so it rules out reflection. The shape does not look rotated in any manner, it simply looks translated. So that's the reason why the transformation here to move us from P to Q is a translation. However, they don't want you to just write down translation or slide as the case may be. They want you to describe it completely. So the first thing we're going to do is state what this transformation is. So we're going to write P undergoes a translation that's the first part of it. We want to describe it completely. So how are we going to describe it completely? Well, we need to describe the translation vector. So some people were able to simply write P undergoes a translation and state the translation vector. Some weren't too successful with stating translation vector, neither were they too successful with figuring out what this shape would have been translated by. So here's how you're going to do it. First of all, we need to look at our object. All right, so P is the object, Q is the image. If I look at P, I'll choose any points on P. So I'll go with this vertex here, which is at 7, 2. Now I'm going to use this as my reference point to figure out what is my translation vector, which took me from P to Q. From here, I'm looking for the corresponding vertex in quadrilateral Q. So I notice that the corresponding vertex is here. Alright, so let's see. How many spaces did I move to go from this point here to this point here? So we're going to look at the x-axis first. On the x-axis, let's see how many spaces we moved. We moved 1, 2. 2 units in the x direction. So we're going to write P undergoes a translation of 2 units in which direction? So did we move to the left or did we move to the right in the x direction? We moved to the right. So we're going to write that down. So P undergoes a translation 2 units to the right. But did the shape form here? No, it didn't. It formed lower down. So let's see how many we had to move this point down by so that we get to this location. We moved 7 units down in the y direction. Since we moved down, we'll come to the translation vector in case anybody wrote the translation vector. So you see what it looked like. So you'll know if you were correct or if you were incorrect. But we move down on the y-axis, all right? So we're going to write after this part of the translation 2 units to the right, we're going to continue by saying and 7 units down. Alright, 7 units down. So for those of you who were able to write down the translation vector, this is what a translation vector would have looked like. The translation vector would have its x movements at the top and the y movements at the bottom. And here we moved 2 units in the right direction, so we would have a positive 2 for our x movement. And since we move 7 units down, we would have a minus 7 for our y movement. So this is what your translation vector should have looked like. 2 minus 7. Alright, so stating translation and then completely describing that translation, you would have gotten 2 full marks. For those of you who would have done the translation vector, once you said that the transformation was a translation and you also stated a translation vector correctly, you would have gotten your 2 full marks.